Example 2, characteristics of parabolas. The parabolic mirror for the California Institute of Technology's Hale telescope at Mount Palomar has a shape modeled by this equation here, where x and y are measured in inches. What is the focal length of the mirror? Now, this focal length, basically, it can be used two ways, but we'll consider it here as being the distance to the focus from the vertex. That's how we'll think of it here. And then I'll give a second thought about it as well. And so here's what you need to determine. On this equation, if we wanted to look at the previous ideas of like how to find the vertex and all that, you would look first in the parentheses and you'd see that there's no shift. So here we have a vertex at 0, 0. And then we could determine where the focus would be by saying, okay, this is 4p, and if 4p equals 2,668, this is in inches, then our focus would be how many inches away. You divide by 4, and I believe if we type that in the calculator, we get 667. That would be the value there. So this started in inches, and so I'll put inches here as well. And so this would be our p. Now, that p is next to x, and it's positive, so you'd add that to the x and say the focus would be located at 667, 0. And so you can see that there's a difference of 667 inches. This would be the focal length for all practical purposes. Okay, now I want to go back, though, and talk about like just a real quick graph of this. What this would mean is it is a horizontal parabola, and what's different about this one is it will go through 0, 0 and come up like this and do the same thing going down here this way. But wherever that focus is, I'll just put it here. We'll say this is 667 inches from this point to that point, 667. What this 2668 would be referring to is the distance across. This would be called the lattice rectum, which is a very weird term, but that right here, this distance across would be 2,668 inches across. That's what that is, and that's called the lattice rectum. That is on your vocabulary page at the start of this unit, at the start of the assignment, up over here. You'll see it right there. It's that term. That's what that's referring to. And it would be the distance across. So I've seen people talk about focal length being this way and this being the focus distance. But on this particular scenario, I'll just leave that as this distance to the focus, because that's how we're going to use it mostly in this class, is finding, because most of the applications are how far away is this from here that we're going to deal with, and so I'll just leave that as my answer there. So with that being the idea, go ahead and solve this problem, solving it the same way for that distance from the vertex to the focus.